Hey guys, welcome back to lesson 6-6 on factoring, which, funny enough, is just another feature of the distributive property. So today's date is 2/11/2020. Oh, just a few days from Valentine's Day. Buy your Valograms. All right, so let's remind ourselves about the distributive property. Distributive property. Yes, spelling matters. Learn to spell. So, a couple of things that are very interesting about the distributive property is that there's always multiplication involved. Always, always. Okay. But there's a choice between what happens inside the parentheses. It's either adding or subtracting inside the parentheses. Clink, sorry about that noise. And so the upshot of this is that there's two different operations. So multiplication is always one of them, and adding or subtracting is another one. Okay. Now, what's interesting is that there can be more than two terms inside the parentheses. You could have adding and subtracting going on in there. Now, the big thing about distributive property is that it has the ability to remove parentheses. And we talked about how if you can't add x and 4, then you wouldn't be able to do any math. However, we can with this distributive property. So we multiply the outer term, and the outer term can be in the front or in the back of the parentheses, by each term inside the parentheses. Okay, so we'll do a couple of examples of this. So I probably am going to do the factoring on a second screen, but it still should be on the first page. This with the example should take no more than half the page. So directions say simplify. And our first problem would be 5 times the quantity x plus 5. So when I distribute, I'm going to multiply 5 times the x, and then it says plus, so then I write plus. Then I'm going to multiply the 5 times the 5. And if you guys remember, this is what I call the brain step. Okay, now, what's the result of that brain step? Well, 5 times x is 5x, and 5 times 5 is 25. Okay, so original problem equals answer, minimum I need to see. Second problem, and that would be, let's see, 12 times the quantity 2x plus 7 equals, and then we're going to distribute, and we're going to multiply 12 by each of the terms in the parentheses. So I have 12 times 2x, and then it says plus, and then I'm going to multiply 12 times the 7. Okay, so first you might say, whoa, how do I do this when there's two numbers there? Multiply them. You can do 12 times 2, that's 24, and the x comes along for the right. Okay, then plus, and then 12 times 7 is 84. Okay, so I'm going to go to the next screen, but again, we're about halfway down the page, not even quite halfway. And I want to do factoring all on its own, so you can see that. So this is not a new page in your spiral. Okay, so let's talk about factoring. Well, you know how we just got rid of the parentheses by distributing? Well, now we're going to put the parentheses back in, okay? And that's what factoring is all about. So we're going to rewrite an algebraic expression so something like 24x plus 84, the result we just got when we did our multiplication, as the product of its factors. So we're going to turn it back to what it was originally. So we would have 12 times the quantity 2x plus 7. Now, can it be any number that I put outside? And the answer is no. Okay? Now, if you look at 24 and 84, and you look what I pulled out, 12 happens to play a very special role, and that role is called GCF. So we're going to have it be the GCF times the remaining expression. Now, you should have nothing left inside of that expression that you can still factor out. So no common factors left. That's what it's going to look like. So the process to get this, we're going to factor out. That's the term we use, and that means to the outside. Outside of what? The parentheses. Okay. Factor out to the outside the GCF of all terms, the greatest common factor of all terms. Okay. So I'm going to write GCF over here just in case you forgot what it was. I'm going to say GCF, greatest common factor. Okay. Then the remaining parenthesis, or the remaining expression, stays inside the parentheses. Okay. So I'm going to show you, remember that factor ladder we did when we were practicing GCF, LCM, that kind of idea? I'm going to show you how awesome it is to use this for factoring expressions. I know you guys don't believe me, but trust me, this is going to be fantastic. So let's start with that 24x plus 84. And we're going to look for a common factor. It doesn't have to be the GCF because a lot of us don't recognize what goes into 24 and 84 is the greatest would be 12. So what I can say is, hey, they're both even. So let's factor out a 2. Okay, so that's going to leave behind 24 divided by 2 is 12. So I get 12x plus 2 goes into 84 42 times. Okay, but both of those numbers are still even, so I can pull out another 2. So 12x divided by 2 is 6x, and 42 divided by 2 is 21. And here's where you got to think. You got little stinky 3's hanging out, right? 3 can go into both of those, and 6x divided by 3 is 2x, and 21 divided by 3 is 7. Okay. So I'm going to take these guys, the vertical guys, and remember what we did before, that's your GCF. So the GCF is going to be the product of all those vertical factors. So 2 times 2 times 3, which is 4 times 3, or 12. Okay. So then we take that 12 and we multiply it by what's remaining. So that goes in the parentheses, the 2x plus 7. Okay, so again, let's take a couple little notes over here. GCF is the product of the vertical factors. Okay. the second factor in the parentheses is the expression at the bottom. Now we can do this with numerical expressions too. It doesn't have to just be algebraic. Of the factor ladder. Okay. All right, we've got a couple of examples and then that'll be it for us. So let's go to the next page. I'm going to go ahead and title it Factoring, or Lesson 6-6, Factoring. And the date is going to be 2/11/2020. So directions are going to say factor the expressions. And we've got 12 plus 8. So here's an example. We're going to do a couple numerical expressions and then we'll do a couple of algebraic. So you might be able to look. I'm just going to do, like, I have no clue the greatest common factor. So I'm just like, nope, they're both even. So let's factor out a 2. So that gives me 6 plus 4. Guess what? They're both even. So I'm going to factor out another 2. And that's going to give me 3 plus 2. And you might say, well, why don't we just add things up and whatnot? Because factoring is asking us to do something else. So we're going to take the vertical factors for the GCF. So we multiply them and we get 4. So that's 4, and then we're going to go ahead and grab the expression that's at the bottom, and we get our final answer, 4 times the quantity, 3 plus 2. Next we have 80 plus 56. Okay, and so again, I don't know, they're both even, so let's pull out a 2. That's going to give me leftover 80 divided by 2 is 40. Ooh, 56 divided by 2, let's see. 2 goes into 5 twice, which is 4 with 1 left over, and 2 goes into 16 8 times. Okay, and then you might say, wait a second, 40 and 28, I think 4 goes into both of those, so let's factor out a 4. So let's see, 40 divided by 4 is 10, plus 28 divided by 4 is 7, and then I notice I can't do anything more with the 10 and 7, so that's my hint, I gotta stop. I'm going to go ahead and take these vertical factors, and when I multiply them, they're going to be my GCF. And 2 times 4 equals 8. So I have 8, and then I'm going to multiply it by the expression that's left over. So 10 plus 7. And that's that answer. Okay, so let's get some algebraic expressions this time. So number 3, we've got 16 plus 4x. 16 plus 4x. And we're going to use the factor ladder. What's something that goes into 16 and 4? A lot of you can say, that's 4, 4, 4. I can hear you shouting right now. So you're sitting there taking your notes. Oops, as I throw my pen. 16 divided by 4 is 4. 4x divided by 4. Well, 4 divided by 4 is 1. 1 times x is x. That's me using that identity property of multiplication. So that's it, man. I don't even have to calculate the GCF. It's 4. So I get 4, and then grab that expression at the bottom. 4 times the quantity, 4 plus x. All right, this is getting easier by the example. Okay, 36x plus 30. Oof. Okay, well, good thing I know my math facts, huh? Well, I know that 6 goes into both of them, so let's try starting there. And let's see, 36 divided by 6, that's going to be 6x, and 30 divided by 6 is 5. Oh, look at that. There's nothing, no numerical factors they share in common. So I'm done. That was easy. I forgot to circle my boo-boo. Hold on 1 second. I don't know who that was. I'm so sorry. I usually have my phone off. That's crazy. Okay, so GCF. is 6. And we're going to have 6 times the quantity, this guy right here, 6x plus 5. Sorry for that very unprofessional interruption, and our answer is 6 times the quantity, 6x plus 5. All right, have a good time with this, guys. It feels so exciting to do algebra. All right, talk to you later. Bye.